A language model can sound brilliant, but it may not know the exact document you need. RAG is the method that gives it a way to look things up before it answers. RAG means Retrieval Augmented Generation. That sounds technical, but the idea is simple. Instead of asking a model to answer only from what it learned during training, we first retrieve relevant information, then ask the model to generate an answer using that information. Think of it like an open book exam. A student may understand the subject, but if the question asks about one exact paragraph in one exact manual, the student should check the book. RAG lets the model check the book. Large language models are trained on huge amounts of text, but they do not automatically contain every private file, recent policy, product manual, support ticket, or research note. They also do not magically know when your organization changes something yesterday. A useful way to picture RAG is as a brain extension. The model is still the reasoning and writing engine. The retrieval system is the memory shelf it can search when the answer depends on specific facts. RAG has two main jobs. The first job is finding the right information. The second job is turning that information into a helpful answer. If the retrieval is bad, even a strong model can produce a weak or misleading response. Imagine asking an AI assistant, "What is our refund policy for damaged items?" Without RAG, it might give a generic answer. With RAG, it can search the company policy page, pull the relevant section, and write a response based on that source. The information RAG searches is often called a knowledge base. It can include manuals, web pages, PDFs, help center articles, internal wikis, transcripts, or database records. The key is that the system needs access to trustworthy material. Before a RAG system can answer questions, it usually prepares the documents. This preparation is called indexing. The system takes raw files and turns them into a searchable form that can be quickly matched to future questions. Most documents are too long to send into the model all at once, so the system splits them into smaller pieces called chunks. A chunk might be a paragraph, a section, or a group of sentences that should make sense on its own. Chunking sounds boring, but it is one of the most important parts of RAG. If chunks are too tiny, they lose context. If chunks are too large, they may bury the useful detail inside too much noise. If this kind of AI explanation helps you understand the tools behind the hype, consider subscribing. We keep things practical, visual, and beginner-friendly so you can follow what is changing without needing a computer science degree. After chunking, many RAG systems create embeddings. An embedding is a numerical representation of meaning. You can imagine each chunk of text becoming a point on a giant map where similar ideas are placed near each other. This is different from simple keyword search. If you search for laptop battery problems, a meaning-based system might also find a chunk that says notebook power drains quickly. The words are not identical, but the ideas are close. Those embeddings are stored in the special search system, often called a vector database or vector store. Its job is to quickly find chunks whose meaning is close to the meaning of the user's question. When a user asks a question, the question is also turned into an embedding. Then the system compares that question embedding to the stored document embeddings and retrieves the closest matches. The closest matches are often useful, but they are not guaranteed to be correct. Similar language can point to the wrong topic. A question about account cancellation might accidentally retrieve a section about subscription pauses if the wording is close. Many RAG systems add a second filter called reranking. First, the search step gathers possible chunks. Then a more careful model or scoring method reorders them, so the most relevant evidence is more likely to reach the final prompt. Now the retrieved chunks are placed into the prompt, along with the user's question. This is the augmented part of Retrieval Augmented Generation. The model receives both the question and the reference material it should use. When the model answers from retrieved material, we say the answer is grounded. Grounding does not mean perfect truth. It means the response is tied to specific sources rather than only to the model's general memory. A good RAG assistant can show where its answer came from. That makes it easier for a person to check the source, catch mistakes, and decide whether the answer should be trusted for the task at hand. One common misunderstanding is that RAG retrains the model. Usually it does not. The model weights stay the same. RAG changes what information is provided at answer time, like handing the model notes before it speaks. Training is like teaching a person a skill over a long period. Retrieval is like letting that person open a reference book during a conversation. Both can be useful, but they solve different problems. RAG is especially useful when answers depend on changing information, private knowledge, detailed manuals, or large collections that would be too expensive or impractical to put directly into a model through training. RAG is not the answer to every problem. If the task is creative writing, broad brainstorming, or simple conversation, retrieval may add little value. If the source documents are messy or wrong, retrieval can make the answer confidently wrong. The first failure mode is missing evidence. If the right document was never added to the knowledge base, the system cannot retrieve it. The model may still answer, but the answer is no longer grounded in the needed source. The second failure mode is bad chunking. A policy might say a refund is allowed in one paragraph and list the exceptions in the next. If those paragraphs are split apart, the model may see only half the rule. The third failure mode is retrieving the wrong thing. The system may find text that sounds related, but does not actually answer the question. This is why retrieval quality matters as much as model quality. The fourth failure mode is stale information. A RAG system can only stay current if the knowledge base is updated. If old policies remain in the index, the assistant may repeat outdated rules with a confident tone. The fifth failure mode is conflict. Two documents may disagree. One page may say the process changed, while another still shows the old process. The system needs a way to prefer newer, official, or higher quality sources. Another risk is unsafe or malicious content inside the retrieved text. A document might contain instructions that try to hijack the model's behavior. Strong RAG systems treat retrieved text as evidence, not as a command that must be obeyed. Better RAG usually starts with better knowledge management, clean documents, clear titles, useful metadata, version control, and good access permissions make retrieval easier. The model cannot reliably organize chaos after the fact. Metadata is extra information about a document, such as its date, department, topic, language, or access level. It helps the system narrow the search before looking at meaning, which can reduce irrelevant results. RAG also needs security boundaries. If a user is not allowed to read a document directly, the assistant should not reveal that document indirectly. Retrieval should respect the same permissions that protect the original information. You test RAG by asking real questions and checking the whole chain. Did it retrieve the right sources? Did it ignore bad sources? Did it answer only what the evidence supports? Did it admit when the evidence was missing? One sign of a mature RAG system is that it can say it does not know. If the sources do not contain the answer, the safest response is not a clever guess. It is a clear explanation of what was and was not found. RAG is not just search, and it is not just chat. Search gives you documents to read. Chat gives you fluent language. RAG combines them, so the system can find evidence and then explain it in a human-friendly way. The main trade-off is control versus complexity. RAG can make AI more useful for real knowledge work, but it adds moving parts. Documents must be prepared, retrieved, filtered, secured, and monitored over time. Here is the simplest way to remember it. The model is the writer. The retriever is the researcher. The knowledge base is the library. RAG works best when the researcher finds the right pages before the writer starts writing. If you still have questions about RAG, chunking, embeddings, grounding, or AI memory, leave them in the comments. And if you want the next explainer to go deeper into vector databases, agents, or fine-tuning, suggest that too.